Let's talk about HSMWorks inside of SolidWorks. First thing we need to do is we need to open up our part file. Here I have a vice jaw. And we need to make sure our cam tab is selected. So we don't want to have our features or our sketch or any of the other tabs. We want cam tab. There we want to have our cam manager tab over in the feature tree selected. We go up to job and we click on job. We're going to select the job for every different operation in our work. So every different work holding we're going to have, we are going to select a new job. So this is our first job. It's going to be Op 1. On the left-hand side here, defaults to milling, which is what we're doing here. This comment would show up on a setup sheet for your setup machinist. If you wanted to convey any information to the setup machinist on the setup sheet, to the whole job, maybe where your work coordinate system is located or the stock or what type of work holding you're using. This model, you can click in this area if the model did not select itself, but this one self-selected and populated the model that we're going to be machining. Since there's only one model in the page, it defaulted to it. But if you are having more of an advanced setup where you have an assembly in here, a lot of times what will happen is you'll bring your work holding in a vise, and then within that vise assembly you'll have your part. So in that case you would have to click on the part that you're going to machine and make sure that's what's identified in the model. Next we have is our stock. We're going to define our stock for a couple reasons. It is going to come into play for some tool paths where it'll figure out where to start and stop machining, and it'll be good for simulations. So there's several different ways to select your stock, and if you notice, if you hover, you can get these pull-out windows that also help you explain what's going on. The fixed size box, a cylinder, tube, that's pretty interesting, a solid. So you can choose a couple different stock options. We are going to default it to relative size box, which fits my part exactly. So what we're going to do is we're going to go for a fixed size box because we're going to cut this part from rectangular bar stock. Here's the finished part sizes that populated in here. The bar stock we're going to make this vice jaw from is it's 2-inch by 1-inch bar stock, and we're going to cut it to length. So the length we're going to cut our stock is 6 1/8 inches. You can see that we grew on the end of the stock here in X. Next for Y, our stock is 2 inches. Our part grows in Y. I'm going to see if I can get to the top of our part here, give you a little better representation of how that grew. And then before I do Z, I'm going to go to the side. And my stock is 1 inch thick. Now it defaults to putting my model in the center of these 3 areas. And for this case, that's going to be fine. But you can also select to offset your stock up or down within or offset your part within the stock up and down by choosing these options and then typing in what your offset is going to be. Ours is going to be fine, just being centered in Z. So cool, we've got our stock defined. We are not using a fixture here, so we're not going to define our fixture. Now, a lot of times your work coordinate system does not lay out properly. In our case, it did, where the blue arrow is our Z, the green arrow is our Y, and the red arrow is our X. And these are all positive directions here. So this one happened to work out just fine because the whole program genome actually matched it. A lot of times you will have to go in and place your work coordinate system in the proper orientation. This one is a very basic introduction, so I'm just going to use stock and orientation. I want to put my WCS back in this corner here. So it is going to be on the top plane, but I'm going to choose top corner 3. That's where I'm going to touch off and establish my Z. The machine here is when you are going to simulate with a multi-axis machine. We want to make sure the machine doesn't hit itself. We are just using a simple 3-axis mill, so we're not going to worry about it. Program name is actually your program number. I'm going to use 5000 for my program number. Program comment is exactly that, comment. So this is a Kurt Weissjaw pre-grind. This jaw is going to have to be carburized and ground to final dimensions. The offset number, this is where it's going to set G54, G55, and G56, all the way through 59. If you have only one operation and you leave this 0, it's going to default to G54. But this is going to be a 3-op job, so we need to make sure that this job is assigned to G54. So we're just going to click the up arrow, and number 1 equals G54. Number 2 is G55, 3 G56, and so forth. We're going to make sure we have 1 selected. Once you've filled those out, just click the green check. So this is what the job looks like once you have it posted. Now I can start adding tool paths to that job. But I think since this video is just about job, let's make this a little better. I'm going to right-click and edit. No, I'm not. Another way to get in there. Look at that. Just showed you how to get in there. But I'm going to, can I rename? Yeah, we can go to rename. And what we're going to do is put something useful in there. Call it op1 top. There. And that's a little more useful than just job. So that's what my technique is.